This is going to be a sort of a longer problem. I'm going to save the algebra for you to do. So I'm going to trust that we can evaluate numbers inside of functions at this point, because I don't want to spend too much time on the algebra. But I want to graph a fifth degree polynomial using techniques from calculus. So let's give ourselves a sketch of the Cartesian plane. This function takes in t values, so our domain is t. And we know it's a fifth degree polynomial with a positive coefficient out front. So we know the end behavior is going to do something like this. And it's a fifth degree, so we're allowed to turn around 4 times. So 1, 2, 3, 4. It might look like that. But let's see what actually happens. So our first step in figuring out the graph of this function isn't going to contain any calculus at all. From your time in algebra, if p of t is equal to t to the fifth minus 5t cubed, and you want to search for the intercepts, the x-axis intercepts, or I guess I should say t-axis intercepts, we will set this equal to 0 and pull out a t cubed, and we have t squared minus 5. So that's further going to factor as t cubed times t minus square root 5 and t plus square root 5. So we have zeros at the origin at minus square root 5 and at positive square root 5. All right, so because we know our end behavior, it's going to do something like this. And who knows what it does in between minus root 5 and positive root 5. But there's 3 of my zeros, right? Because we had multiplicity 3 at the origin. And there's the other one for the total of 5 zeros for this fifth degree polynomial. All right, so we know it's going to do something like this. Now, back in your days of algebra, you didn't know how high you needed to go before you turned around. But now that you have calculus, you can search for those horizontal tangent lines. So let's do this. The tangent lines are given to us by the derivative. And if we differentiate our function, I'm going to use the unfactored form, so I don't have to use a product rule. This differentiates to 5t to the fourth minus 15t squared, which we're going to factor by pulling out a 5t squared, and we're left with t squared minus 3t. Oh, sorry, no t's on that 3. And that's further going to factor as 5t squared times t minus root 3 and t plus root 3. So our graph has horizontal tangent lines, right? Our derivative is equal to 0 when t is equal to 0. So I'm going to draw a little horizontal tangent line right there. And we also have horizontal tangent lines at minus root 3 and positive root 3. Now, I don't know where the graph exists there, right? Is it going to do this, or is it going to go up a little bit higher? So let's figure out our function values at those points. If we plug minus root 3 into our original function, we're going to get about 10.39. So somewhere up here. So we're going to increase until we hit that point, and we're going to, for a moment, have a horizontal tangent line, and we're going to turn around. All right. Where else do we have horizontal tangent line? Right there. And our first derivative has multiplicity 2 at that horizontal tangent line. So we aren't going to turn around. We're going to move past it. We also knew that because this was an odd degree, so we were going to pass through it with cubic behavior. We're also going to find out that we changed concavity there. And then the function at square root 3. So how low should I go? Here or here? The function at square root of 3, it's an odd function, so it's going to be minus 10.39. So we're going to go down all the way here, and that's where our horizontal tangent line is going to be before we turn around. All right, let's double check that our concavity is correctly. Right, where exactly do we change from concave down to concave up? So concavity concerns the second derivative. And if we differentiate this twice, we have 20t cubed. I'm looking at that derivative right there. 20t cubed minus a 30t. So our second derivative is allowed to change sign either at discontinuities, just like we've been doing, or zeros. So let's solve for the zeros. Let's pull a 10 away and a t, and we're left with a 2t squared minus a 3 and nothing. So this is going to have zeros at 3 over 2 plus or minus the square root of that. And that has a 0 at 0. So we're going to change concavity at minus square root 3 over 2 at positive square root 3 over 2. So somewhere right there. Right at that moment, we're going to change from concave down to concave up. And then also when t is equal to 0. And we kind of already have that drawn. At the origin, we change from concave up to concave down. All right, so now with the tool of calculus, you can give a lot more detail to your graphs than you could in your days of algebra.